All right, now I think we're here. I mean, this is like, I'm ready to actually start trying to do, yes, settle down outside the room. I'm ready to try to start actually doing the neural network training. So just to kind of recap, hopefully you've watched some of the videos that are leading up to this particular one. But what I have right now is I have a JavaScript program that loads data for 800 doodles of cats, 1,000 doodles of cats, 1,000 doodles of trains, 1,000 doodles of rainbows. All of these doodles come from the Google Quick Draw dataset, which I covered in previous videos. Now, what I have also done is prepare the data and separate it out into about 80%, 20%, 80% for training and 20% for testing. So the first thing that I want to do now is I need to create a neural network that will work with this data. It needs to be able to receive a single image as input with 784 pixels, and it needs to give me an output with 3 numbers, which each represent a likelihood or like a score of how likely it is to be of a given category. So we can think of maybe this category will be cat, this category will be rainbow, and this category will be train. And so let's actually set something up, because we're ultimately, everything boils down to numbers. I mean, we think of this as an image and we think of these as string labels, but it's going to make sense for us ultimately to use numbers. So what I'm going to do just really in the code really quickly is I'm going to add at the top some constants like cat equals 0, rainbow equals 1. So this will be kind of a mapping. Rainbow, what was the other one? Train equals 2. This will map each one of those categories to a number. I already have, as part of my index.html file, a reference to my neural network library. So when I release this code, when I release this example, and you're looking at the video description to find a link to the code, you will find it with this library included. And what this library's repository is here on GitHub under toy neural network.js. And what it allows me to do, if I go back to my main sketch, is I can create a variable. I'm going to call it, dare I call it NN for neural network? I'm going to. NN for neural network. And I'm going to say NN equals a new neural network. So, what arguments go inside the parentheses there? The way the library is designed, and this is not universal, is first I need to say how many inputs are there, 784. Second, I need to say something else. And third, I need to say how many outputs I want, which in this case right now is 3. The second argument is how many hidden nodes. Now you're going to want to go back and watch my neural network, build a neural network playlist, where I go much more into detail about what the hidden nodes are and how they work. But right now, the hidden nodes, it's really, you can think about it as the kind of magic in a way that's in between the input and the output that allows it to make that allows it to learn. And so the more hidden nodes we have, the more parameters there are, the more things, the more sophisticated in a way the neural network can be. Now, of course, there can even be not just the number of hidden nodes. If there's input, hidden, and output, what I'm talking about is sort of vertically how many hidden nodes are there. But there can also be more hidden layers. But this is, again, kind of beyond the scope of where we are currently in my videos about machine learning and neural networks. Right now, the library, I'm going to just assume there's 784 inputs. There's one set of inputs with 784. There's one set of outputs with 3. And then there is a hidden layer, which I'm going to arbitrarily just say, I don't know, 64 sounds like a good number. And if maybe things aren't working very well, maybe I'll try making it higher. If it's running too slow, maybe I'll try making it lower so there'll be less math for it to do. We'll just sort of play around with it. OK, so coming over here, I'm now going to say 784. Then I'm going to say, I've already forgot, 784, yes, 64 and 3. So this is my neural network. 784 inputs, 3 outputs, and 64 hidden nodes. And and I think I'm good. I'm good. I'm done. No, I'm not done. Now what I want to do is I want to train it to learn, I don't know why I'm all caps all of a sudden, about cats. So what I want to do is say for let I equal 0, I is less than cats.training.length. How many training data sets are there? I++. Then what I need to do, so here's the thing. By definition, this is a cat. So I need to say, let me create the outputs. Okay, so I just realized something. Here's a terrible idea that I was about to do. Let me train the neural network with all 1,000 cats. Now, let me train the neural network with all 1,000 trains. Now, let me train the neural network with all 1,000 rainbows. This is no good. I need to, in order for this to work effectively, I need to just be training it with all the training data in random order. So it's like cat, rainbow, train, rainbow, cat, train, cat, rainbow, train. So I'm going to need to do, I thought I prepared all the data in the previous video. I'm going to have to do some more work preparing the data. And so one thing that I think that I can do is I can actually pass in, what I'm going to do here is pass in the label. So this is a cat. This is a rainbow. I'm going to give it, and this is a train. I'm going to add another argument called label. And what I'm going to do, this is a little bit goofy, but you can do this kind of stuff in JavaScript. This array, I'm going to just give it an additional property. And I'm going to give it that label. And I'm going to call it label. So it's a little bit goofy how I'm using the same variable name everywhere, but I think in the end it's going to make things make sense. I will show it to you in the console. And this is I minus threshold, because I need the testing data. And this is testing, also needs a label. So look at this. Let me just show you what's going to happen now, okay? Now that I've added that in, if I refresh the sketch, let's look at the rainbows. You can see there's still 800 training rainbows, 200 testing. If I look at the testing ones and I look at number 2, for example, this is the array and it has a label of 1. So all of the rainbows should have a label of 1. All of the cats, if I look at just an arbitrary one, 101, have, whoops, and this is a weird thing you can do with JavaScript. Even though it's an array is an object, and so I can attach some other properties to that object as well. So the labels are in there. Now what I can do is, what I need to do is put all of them together into one big array and then shuffle it. So what I should say is, let training equal a blank array, and then training equals training.concat cats.training. Like concat should join it, right? And then just join the rainbows. I don't know if this is right. And the rainbows and the, what was the other one I got? The trains. All right, so here we go. So that is now, let's see what that comes up with. Console log training. Let's look at that. There we go. 2,400. That's 800 times 3. Yeah. Why is there? Oh, yeah. It's 2,400 of these. Wonderful. And look. And now, and this one in here is label 1. Oh, this is good. This is actually making sense. OK, so I have all the training data in here, but I want to shuffle that. I want it to be in random order. So how do I shuffle an array? OK, well, today is our lucky day because it just so happens that P5 has a function in it to shuffle an array. So I'm going to say shuffle training. Now, one thing that's interesting about the P5 shuffle function, and let me just show this to you in the console, and let's make sure this is true. Let's say I make an array, and I say 4, 1, 9, 10. Right? So there's an array. I could say shuffle the array A, and it's giving me back a new array in a randomized order. But if I look at the original array, it's still in the original order. So I could say A equals shuffle A, but another way I could do it, I believe in P5, is say shuffle A and then pass in a second argument that's a Boolean variable, true. And then I get this array again in a random order, but it's actually affected that array itself. This is similar to when I looked at array functions like, does the array function map alter the array or make a new array? This is similar here. So I'm going to say shuffle training true. So, and then I'm going to console log it again. So this was it. It should be like everything at the beginning should just be like 1, 0. Oh, no. I'm sorry. It's showing me. So the problem with console log, by the way, is it tries to be, this happens to me all the time, it tries to be smarter than you. And so even though it's console logging it here, I changed that array. And it, so even though I'm console logging it before I call shuffle, it's there in the console and it's like live updating as the data of that object changes. So I think we're just going to trust that this is working, and I'm going to take this out and I'm just going to call shuffle again. And as I look at it, we should see here, okay, the first one is a 2, the second one is a 0, the third one is a 1. Perfect. It is in random shuffled order. Excellent. So now I can finally go through and train the neural network. This is my image drawing stuff, which I don't need. So I am going to, this is making the neural network. This is preparing the data, making the neural network, and now randomizing. And now we're going to do something very exciting. We are going to train. Train for 1, and what's the word that I'm going to use? I'm going to add a term somewhere. Epoch, which is, in my view, the proper pronunciation of this word, not how I like to, never mind. Anyway, so epoch, or epic, whatever. So 1 epoch is training over all 800 of the training elements. But in this case, it's 800 times 3, so overall 2,400. So I want to say, for 1 epoch, I'm going to say for let I equal 0, I is less than training.length, I plus plus. And I'm going to say the data is training index I, the label is training index I.label. So now what I need is I need the inputs. And let me say, so inputs is training index I, is that array. This is a little bit confusing, but let's think about that. Let's just do this. So for a moment, just so I get a handle on this, I'm going to actually just do one thing. So instead of training over all the training data, I'm going to just train over 1. So let's console log the inputs, and then console log the label. And I just realized I've got a major issue, which is fine. It's a major issue, but I can do this. I actually need to make a new array. I need to make inputs actually has to be a new array. Because what I want to feed, if you remember, I talked about this in one of my earlier videos, I don't want to feed in the raw bytes of a number 0 through 255 into the network. I want to feed in a normalized number. So that byte value, which is an integer or a byte between 0 and 255, I want to divide that by 255 to get a floating point number. So I'm going to make a new array. Again, I'm not worrying about being efficient here. And I'm going to say I'm going to say for, I'm going to do another loop. I'm going to say, just use j. J is less than training index I dot length, right? Which I know is going to be 784. So really, I can use that global variable, j++, and I'm going to say inputs index j equals training index I index j. Oh boy. Let's make another variable, data equals training index I. That way I can just say, this I can say data.length And now I can just say inputs j equals data j divided by 255. I can't override that data because that's an integer. This training array is reserved to be integers. So now I have the inputs. The inputs should be 784 floating point numbers. And then, so let's look at that. Let's look at the inputs and, let's look at that. Let's look at the inputs and then let's look at the label. So we can see there are the inputs. Let's go into the middle somewhere where we have some color values. Oh, there we go. So we can see these values have been normalized. Now we have floating point numbers between 0 and 1. Those are the inputs. Now, let label, and the label is, for this particular one, is 2. Now here's the thing. What I need for the outputs is an array that has three values in it. It should have zeros for the category it is not, and a 1 for the category it is. That's often, by the way, referred to as one-hot encoding. It's an array that has only one, it's a vector that only has one element with the value of 1, everything else 0. So the way that I could do that is I can say, let targets now be an array with 3 zeros in it. And then I could say targets index label equals 1, right? Because remember that label is a 0, 1, or 2. So I either want this to be 1, this to be 1, or this to be 1. And now I can say console.log targets. So let's do that. Let's run this. We can see, look. Now, every time I run this, I'm going to get something different. Because remember, it's shuffling the array a different way. But we can see, I got a lot. We can see this is working. I'm getting an image with 784, not an image, but an array of 784 floating point values. And I'm getting the target outputs. So finally, I can say neural network train inputs targets. So what is happening inside of this function? So to really dive more deeply into what is happening inside this function, you've got to go back and watch my playlist where I build the neural network library itself and write the code for the training function. Just to give you an overview, an idea here is what we're saying is, hey, neural network, whatever state you're in, take this input data and give me some outputs. And maybe those outputs, it's going to make a total guess. So those outputs are going to be some arbitrary numbers, like 0.4, 0.9, 0.003. It's going to just come up with some numbers. It's going to be random when it starts. But I've also given it targets. And maybe I said the targets are 1, 0, 0. So this is its actual guess, its prediction. And these are the targets. And so what the neural network is able to do is calculate an error. And the error is really something quite simple. It's just the difference between, and I mean subtraction when I say difference, between what it guessed and what the targets are. And it uses that difference as a way of internally adjusting a whole bunch of dials, which are essentially the weights of all of the connections between the inputs and the hidden layer and this output layer. So you can go back and watch my neural network playlist to dive into how that process works more deeply, but that's basically what the library is doing. So now, in theory, if I run this, and I'm going to take out this console log, and I'm going to put this back in, I can say console.log trained for 1 epoch. We're stuck. Is it just taking a long time, or are we really stuck? It just took a long time. So that can take a while, right? It's slow because I haven't done anything to optimize my code. It just, and really what I might want to do is put this in the draw loop and have some kind of animation. But I'll come back to that. Maybe we'll add that in a future video. I just want to see now what happens Well, let's evaluate it. Okay, so wait, actually, you know what? We're good. I gotta stop here. I mean, we don't know if it's worked, but I think this is a good point to stop and take a break and get ready for the next video. Because what is it that I need to do? I now need to test how it did. So the next thing I need to do is give it all of the test data. Don't train with it, but just evaluate how well it does with all of that testing data. So that's what I'll do in the next video. Then, of course, what I ultimately want to be able to do is I want to be able to use my mouse to draw a nice little train or rainbow or cat into this canvas right here and have it guess what it is. Okay? So, hopefully this video about training has helped. I know we're not seeing anything yet, so we haven't gotten to the exciting part, but we have now trained over all of the training data. And if I looked at the neural network, it's still there. You can see it has some input nodes. You can see it's got stuff in it. I got to talk about the learning rate. We'll get to all this stuff later. Okay, see you in the next video.